Alright, so let's start with the first one. What would we do with sine of 15 degrees? Determine the exact value.
We would do plus 30 sine of 15 plus
Close. What I want to do is I want to write 15 degrees using some of the special angles that I know. So how can I write 15 degrees using some of the special angles that I know? 45 minus 30. And then we look up the formula because the teacher said he was going to be nice and wasn't going to make us memorize them. So if I have sine of something minus something, it goes sine of the first one, cosine of the second one, minus, and then you flip them, cosine of the first one, sine of the second one. All right, so this means we need sine 45 degrees, cosine 30 degrees, minus, flip it around, cosine 45 degrees, sine 30 degrees. All right, and then we just fill it all in because we've memorized all these values. Sine of 45 is square root of 2 over 2. Oh, we know that one well. Cosine 30 degrees is square root of 3 over 2. We're on a roll today. Minus cosine of 45. Square root of 2 over 2. And finally, sine of 30. 1/2. So we get square root of 6 minus square root of 2 all over 4. Questions on that one? Square root of 2 times square root of 3? Square root of 6. Okay, how about tangent of 7 pi over 12? Again, what I want to do is I want to write 7 pi over 12 using angles that I know. How can I get 7 pi over 12? Pi over 6 and pi over 2? I don't think so, because pi over 6 plus pi over 2 would be pi over 6 plus 3 pi over 6. The common denominator would be 6. So those two don't work.
3 and 4 would be pi over 3 and
Pi over 3 and pi over 4, that sounds better, because this would be 4 pi over 12, and that would be 3 pi over 12, and they do add up to 7 pi over 12. So dealing with the radians is a little bit harder here. Dealing with degrees is pretty easy to see how to make it add, subtract. Dealing with the radians is a little bit harder. Ian? If you wanted to, I suppose you could convert it to degrees and then work it in degrees. Sure, if you want to. But after a while, you get pretty good at these. So this is pi over 3 plus pi over 4. All right, so once again, I go to my formula chart here. Tangent of add two things together. I do the tangents of each ones and I add them up. And then 1 minus multiply the two tangent things together. All right, so I'll write all that down. That's tangent of pi over 3 plus tangent of pi over 4 over 1 minus tangent pi over 3 times tangent pi over 4. We keep the tangent in just like we kept the sine and the cosine in back here.
Oh, yeah. But
then we're actually going to evaluate them. Because now I'm going to ask you, what's the tangent of pi over 3? Is it root 3? I guess so. Plus tangent of pi over 4. It's not 3, it's 1. 1. Divided by 1 minus tangent of pi over 3. Still the square root of 3, it hasn't changed. And the tangent of pi over 4? Still 1. That one hasn't changed either. So there's our answer. That's it. Well done that one. I don't think so, because there's nothing that factors out. I mean, if you really wanted to be picky, you could rationalize the denominator. I'm not that picky. Yeah. Questions on that one? All right, I'm going to skip down to number 2.
Cosine of.
Verify the following identities. Cosine of x minus pi over 2 equals sine x. All right, well, I would start with the left-hand side here. Cosine of x minus pi over 2. What would I do with that? I use one of the identities. All right, so I go to my identities here. If I have cosine of something minus something, I go cosine cosine plus sine sine. Okay, so this is going to be cosine cosine. That's going to be cosine x cosine pi over 2 plus sine x sine pi over 2. And then I simplify. What's the cosine of pi over 2? That happens to be 0. What's 0 times cosine x? 0. So this one's 0. Plus, what's the sine of pi over 2? 1. And 1 times sine is sine. So we do end up with exactly sine x, just like we were supposed to end up with. Questions on that one? They will either always verify, or the teacher made a really bad mistake and typed something in wrong. What's that? No, I wouldn't give you one. If I say verify, then you should be able to verify. It should really be true. I would not say verify and then give you one that's false. True. Yeah. But you wouldn't be able to do anything. Great. All right, so let's try this one. Sine of x plus y minus sine of x minus y. How do I know to start with the left-hand side? True, that's what we've always done, but do we always start with the left-hand side? We do read from left to right. Kind of what you want to do with identities is usually you look at both sides and you start with the side that looks more complicated. So to me, the left-hand side looks more complicated, so I start with the left-hand side. I mean, if this were written the other way, if this was on the left and this was on the right, I still would have started with this. I would have started because that side would have looked more complicated. All right, well, what do we do? Formula. All right. So the formula, if we have sine and we're adding two things together, again, it goes sine cosine, and then we add and it goes cosine sine. All right, so this first part is going to be sine x cosine y. Go ahead.
So which one are we doing? Which identity?
Right now, I'm taking this piece of it,
Okay. Not the subtraction.
and it's going to become this.
Okay.
So this goes to here. And then I'm going to do it with this one too.
Okay, so you don't do it with the...
Right. So I don't do both at once. I do them both separately. All right, so the sine of x plus y, that had sine x cosine y, and then plus, and then it switches. It's cosine y sine x. And then the formula that has the minus in the middle is really the same. It goes sine cosine, and then it goes cosine sine. The only difference is you have a minus in the middle. So it's going to be pretty much the same. We've got this minus out front. We're going to have sine x cosine y, I better write small because I didn't give myself enough room, minus cosine y sine x. So I've got to use two different identities. I use one identity for this one, that's here, and then I use one identity for that one, that's over here. All right, now what? Distribute the minus sign through. All right. Sine x cosine y plus cosine y sine x minus sine x cosine y plus cosine y sine x. And then some really happy things happen. What are the happy things?
Sine x cosine y.
Sine x cosine y, those add up to 0. And what's left? 2 cosine y sine x. So, remember just a minute ago I talked about if the teacher makes a bad mistake? Here's a good example. This is supposed to be 2 cosine y sine x. So the teacher typed that up wrong from the beginning. No, I can't just flip the x and the y, unfortunately. I could write this as 2 sine x cosine y. I could change that order. But unfortunately, I had the x and the y wrong there up in the original problem. No, that was me. I'm the one who types these up. I'm the one who screwed it up. Yeah. Oh, holy crap, you're right. Oh, I did a really bad thing. Because what I did, notice I did sine x cosine y. This one should be cosine x sine y. And you know what? I did it twice. So I didn't screw up from the beginning. I screwed up right here today. All right. We'll do this problem again since I have a clean sheet and you don't. That's mean, isn't it? All right. So this left-hand side, sine of x plus y minus sine of x minus y. This should have been sine x cosine y plus cosine x sine y. They flip. So this one has sine x, this one has cosine x, and that's where I screwed up before. You're absolutely right. And then this one should be minus sine x cosine y minus cosine x sine y. And now it's going to work out. When I distribute the minus sign through here, this one and this one are still going to reduce out. And I'm going to have plus 2 cosine x sine y, because this minus turns that one into a plus. And so, see, everybody screws up every now and then. Mistakes happen. All right. I'm going to skip C and D, and you're going to work on those here in a few minutes. How about number 3? Right in terms of only x and y, we have sine of sine inverse of x plus cosine inverse of y. No, that's supposed to be a minus right there. That's just a minus right there. Looks like an equal. It's really just a minus. What do you do? Any ideas?
Could you distribute in sine squared plus cosine squared y?
Well, I can't distribute because I don't have any multiplication.
It's sine times sine.
It's not sine times, it's sine of. And this is poor math notation. We use these parentheses to mean different things. For example, if I write sine pi over 4, I don't mean sine times pi over 4. This means take this number and plug it into that function. That's square root of 2. So again, this symbol here, this parenthesis doesn't mean multiply. This is function evaluation. So this is take sine inverse of x plus cosine inverse of y and plug it into the sine function. No, not any easy way. What I see is I have sine of something plus something else. I have sine, and then I'm adding two things together inside of here.
So
So I use one of the identities. I go back to this identity where I have sine, and inside the parentheses I'm adding two things together. All right, so that's going to be sine, and then it's the first one, sine of sine inverse of x, and then it's cosine of the second one, cosine inverse y. And then since this is a plus, we have a plus. And then it switches. It's going to be cosine of the first one, sine inverse of x, and sine of the second one, cosine inverse of y. A couple of these things are very, very easy to simplify. What's the sine of the sine inverse of x? It's just x. Why is it just x? Sine and sine inverse are inverses. So they reduce each other out. This one's x times. What's the cosine of the cosine inverse of y? Y, because cosine and cosine inverse are also inverses. So that's x times y plus. Oh, this one's not so easy. What's the cosine of the sine inverse of x? What is x? X is just a letter x. All right, we did these a while ago. It's been a little while.
Yeah, with numbers though.
I think we did it with letters too. Cosine of sine inverse of x. This is cosine of some angle theta, where theta is the sine inverse of x. I'm going to take this little equation right here, and I'm going to do sine on both sides. What happens when I do sine on both sides? If I take this little equation right here, and I do sine on the left, I get sine theta. What happens if I do sine on the right? They cancel. Sine inverse. Sine inverse takes a number, some number. When I plug a number into sine inverse, it gives me an angle. So I decided I wanted to call that angle theta. So this thing, when I use this thing, it always gives me an angle. So I decided to call that angle theta. I just gave it a name. I picked a name that I liked a lot, theta. And then I decided I don't like the sine inverse symbol, so I'm going to do sine on both sides. What this allows me to do is draw a picture. Here's my angle theta. This is a right triangle. If the sine of theta is x, then how can I label this triangle? What can you tell me about opposite and hypotenuse and adjacent? Opposite is x, hypotenuse is 1. Opposite over hypotenuse, x over 1. I could then go talk to Pythagoras and use the Pythagorean theorem, and I would find that the other side, when I work that out, is square root of 1 minus x squared. All right, so we're almost done. What's the cosine of this angle now? Which is square root of 1 minus x squared over 1. So back up here, this thing, cosine of sine inverse of x, that ugly thing becomes square root of 1 minus x squared. I'll put both on the screen at the same time. How's that? Well, here's the bad news.
Do it again.
The bad news is we're not done because we have to do it again for this thing. All right, so again, I'm going to write it down over here. Sine of cosine inverse of y. Number 4 is almost easier because it's got numbers. Again, when I use cosine inverse takes a number, I plug it in, and it gives me an angle. So this cosine inverse thing, I want to call it an angle. What angle letter do I want to use? I don't want to use theta again because I already used theta. Delta, I heard first, so I'll use delta. So I'm going to call this sine of, am I using capital delta or little delta? Triangle, all right. No, I think that's capital. That's little. That's little delta. That's capital delta, I think.
So why is it sine?
Because she told me to use delta.
Why is it sine?
Because, again, this,
Oh, wait, actually, no, I get it.
where this angle delta is cosine inverse of y. We decided to call this angle, cosine inverse gives me an angle, we decided to call it delta. That was our choice. Again, I'm going to do cosine on both sides. That means cosine of delta is, what does cosine do to cosine inverse? Cancels it out, so I'm left with y. All right, now I draw myself a nice triangle. Here's a nice triangle. Here's my angle delta. How can I label this triangle? Adjacent is y, and the hypotenuse is 1. And once again, you could go use the Pythagorean theorem, and when you do, you would find this side is square root of 1 minus y squared. I skipped a step or two there. All right, let's finish this one, and then I'll do a similar one, and we'll go through it again. How's that sound? All right, so my final answer is sine of delta. Looking at the picture now, sine is opposite over hypotenuse, so it's going to be square root of 1 minus y squared. So there's my final answer. There's my answer using only x's and y's. No more sines and sine inverse things. All right, so let me do a similar problem. I'm going to do the sine of the cosine inverse of something. Give me something. What's that? I don't want a number. I want something with letters in it. I don't want to use alpha because alpha usually stands for an angle. So let's use
C.
x over 5. X over 5. All right. Do sine and cosine inverse cancel each other out? No, they're certainly not opposites, are they? They're not inverses at all. So they certainly don't cancel each other out. So again, what I need to recognize is this thing, whatever it is an angle. So I'm going to give it an angle name. What angle would you like to call that? Question mark. That's a funny name for an angle. Theta. Typically we use theta. So I'm going to call this thing right here theta. So theta is cosine inverse of x over 5. I'm going to take this equation and do what to both sides? Why cosine? To make it cancel that cosine inverse. So I'm going to apply the cosine function on both sides of this equation. I'm left with cosine theta equals x over 5. Then what? Draw a picture. Draw a triangle. Okay. The right triangle. This is my angle theta. How can I label this triangle?
Adjacent with the x and hypotenuse would be 5.
Adjacent is x, hypotenuse is 5.
X squared minus 5.
Other way around, 25 minus x squared. Because you'd have a squared plus b squared equals c squared, so you'd have the 25 squared on, or the 5 squared on one side, and then you'd have to move the x squared over. All right, so now we're ready to finish it off. This is the sine of our angle theta, because we call theta cosine inverse. So I look at the triangle. What's the sine of that angle? Opposite, which is square root of 25 minus x squared, over hypotenuse, which is 5.
And you wouldn't reduce the top. Oh, yes, you can.
I can't reduce the top because of the minus sign in the middle. That's correct. So that's it. That's my final answer. Can it what? No, I think that's about as bad as they're going to get.